Here we have an example of converting degrees Fahrenheit to degrees Celsius function. So to find Celsius, C is equal to 5 over 9 times the F value for Fahrenheit minus 32. So we want to draw a graph from 0 to 100, taking the values to the nearest integer. So we're going to go up in units of 10. So in this case, if I let F equal to 0, C is going to be 5 over 9 times 0 minus 32, which is equal to, so use your calculator, 5 over 9 times minus 32, which is equal to minus 17.7, which is minus 18 degrees. If F is 10, then the Celsius is 5 over 9, 10 minus 32, which is equal to minus 12.2, and to the nearest integer, minus 12 degrees. When F is 20, the Celsius is 5 over 9, 20 minus 32, which is equal to minus 6.6 or minus 7 degrees. When F is 30, Celsius is 5 over 9, 30 minus 32, which is equal to minus 1.1 or just minus 1 degree, because it does say to the nearest integer. Okay. When F is 40, the Celsius is 5 over 9, 40 minus 32, which is equal to (4.4), which is just 4 degrees. Okay. When F is 50, the Celsius is 5 over 9, 50 minus 32, which is 10 degrees. When F is 60, the Celsius is 5 over 9. You're replacing F every time. So 60 minus 32, which is 15.5 degrees, which is 16 degrees. When F is 70, Celsius is 5 over 9, 70 minus 32, which is equal to 21.1 degrees or 21 degrees. F is 80, 5 over 9 minus 32, which is equal to 26.6 degrees, which is 27 degrees. When F is 90, 90 minus 32, (32.2 degrees), which is 32 degrees. And finally, when F is 100, the Celsius is equal to 5 over 9, 100 minus 32, which is equal to 37.7, which is 38 degrees. Okay, so there are your values for your x-axis. X always goes across the bottom, and these are the numbers you need to get up to. So this time take your time with this graph, because there's a bit of minuses and pluses in it. I'm going to start somewhere here. I have no minuses on the x-axis, so I'll just go across. So x, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And on the y-axis, I need to get up as far as 38. So 10, 20, 30, 40. Minus 10, minus 20, minus 30. So that should do it for us, okay? And as long as you have enough room on the graph then. So 0 up to 18 degrees. No, sorry, 0 down to minus 18. So I ignored the minus, it's a minus 18, so that one's wrong, okay? 10 to minus 12, which is somewhere here. 20 to minus 7. 30 to minus 1, which would be somewhere in here. 40 up to 4. 50 up to 10. 60 up to 16. 70 up to 21. 80 up to 27. 90 up to 32. And 100 up to 38. And again, you should see a similar straight line graph. And that function represents c equals 5 over 9 f minus 32. Now, as you can see, the same as them all, there's a few questions. So from your graph, estimate the temperature when degrees Celsius, when the Fahrenheit is 85. So 85 will be between 80 and 90. Draw a little line up to our graph. We'll go across from where it hits the graph. So I would say part 1, Fahrenheit equal to 85, the Celsius is equal to 29. So it's just before the 30 line. Estimate from your graph the temperature in degrees Fahrenheit when the temperature in Celsius is 25. So this time in a different color. 25 degrees is between 25 and 30. And this time working backwards down. So I would say that's give or take 75, 76 degrees maybe. So part 2, if the Celsius is equal to 25 degrees, Fahrenheit is roughly about 76 degrees. Okay? So it's an estimate from your graph. It doesn't have to be the exact answer. So it is an estimate, okay? So just be careful with that. And finally then, if the freezing point on the Celsius scale is 0, so on the Celsius scale is going up, is 0, what is the freezing point on the Fahrenheit scale? So where does the Fahrenheit scale freeze? Right? So on the Fahrenheit scale then, where does it freeze once it goes below 0? So this point here is what we call freezing on the Fahrenheit scale. So the questions are straightforward enough and they're always based on the graph, okay?